when I'm talking about Chia, I'm often not sure what to say because it's such a giant, sprawling project in terms of scope. It's very much based off of Bitcoin, but kind of next generation on all the things, including the consensus algorithm, which I will not be talking about right now, although that is its own gigantic project and very interesting, and on-chain programming environment. So we have Chia is up and deployed. We have built some stuff on top of it. We are building more stuff on top of it. So I'm going to be talking not about how you actually do stuff in Chialisp, but just what the big projects on it are. Because the basic tricks for how to actually get anything done in it are also a really interesting subject that gets really technical. So in the interest of being comprehensible, I'm going to mostly be talking about what the projects are with some high-level thoughts on how this interacts with things. So first off, the technical stuff I am going to get into is the coin set model. The Bitcoin is based off what's called the UTXO model. What this means is it's referring to what is the persistent information that this ridiculous database keeps around. So in Bitcoin, everything that it remembers are this horrible name and acronym, the UTXOs, unspent transaction outputs, which are referring to the transaction which created a coin and the index number of the particular output which it happens to be, which is both awkward in terms of terminology and also just very weird, as if every time someone referred to you, they talked about your birth certificate. It's a little strange. But in Chia, it's the coin set model, which is basically the same thing, kind of dumbed down. Mostly in the interests of making it so it can introspect its own coin format. But what this means is that the only thing it remembers is there are a bunch of coins that currently exist. Every coin has a lineage, it remembers its lineage, and it's what's called a puzzle, or puzzle hash, which is the equivalent of what in Bitcoin is called a script key hash. And it remembers its amount, its size. This is everything. This is all there is just a list of these and their birthdays. It supports absolute and relative time locks on these things. The benefit of this is everything kind of interoperates. Like in Unix, everything is a file, and Chia and Bitcoin, everything is a coin. So if you want to talk to a thing, there is this consistent API where anything can talk to anything else. It's very much unlike in Solidity, you wind up having these kind of walled gardens of things where like, for example, thing I'll get to is a token in Ethereum is really just remembering an account amount inside of a thing. And it's a very walled garden for each of those things individually. And you don't have really smart tokens per se. And in Chia, it's actually a colored coin protocol that we've made for these things, and they're like first-class objects. So an important point about the coin set model is it is possible to have both covenants, that is, a thing can put restrictions on all of its descendants, and capabilities, that is, a thing can prove that it was granted some rights by its ancestry. I'm not going to be explaining how, just trust me. It can be done. That's a whole super involved technical thing that is, I think it's really fun and interesting, but it's kind of a lot to try and explain in a talk. So for starters, there are kind of two very most basic things that you ever do with, and I apologize for not having great slides. I'm just going to be riffing off of them because I wound up having not much time to put together slides. So there are kind of two basic primitives that other things are based off of here. So writing Chialisp is not particularly simple. It requires thinking about things differently. The number one thing for making it easier for other people to write Chialisp is to have stuff done already. And so in terms of basic things that you want to do, there are two super fundamental things that we have reference implementations of. You don't have to use them, but they're good ideas. One of them is the concept of a singleton. That is a thing that has a capability that persists over time. It's kind of like the Dalai Lama. And in principle, all Dalai Lamas are the same person reincarnated, and just they shuffle off this mortal coil and their soul goes into a new body. That's what singletons are. You want to interact with a thing. It's not the same coin, but the soul of the singleton has gone into a new thing. So the life cycle of a coin is it's created and then it dies. That's the whole thing. And this is the entirety of the life cycle of a coin. And it can't do anything other than that. So in order to have something a little more persistent, you need to have singletons or something else capability-based, but a singleton is the very most fundamental one of those things.
Bram, can you do just so we understand the comparison to Bitcoin?
Yeah.
Can we do singletons in Bitcoin, or is that something that Chia doesn't?
Bitcoin does not support singletons. Bitcoin could, in principle, support singletons with a little bit of programmatic extension using some not terribly crazy new bits of functionality in Bitcoin script and some information it already has available and some super crazy tricks. And in Chia, we just kind of wrote the entirety of the environment from the ground up to support doing things in exactly that way. So this has been pointed out that you have things which can, in Bitcoin, there's a transaction and it has a script pub key hash in it. And things know, in principle, scripts in Bitcoin can refer to the transaction that they have. They are given that transaction and they can make assertions about it. Now, that is a god-awful thing to try and parse, but in principle, they could parse through it and find out what their own script pub key hash is and do things with that. That would require Bitcoin scripts be able to do a lot more things. And even if it were, parsing that transaction format is horrible. So if you were to try and add this kind of functionality to Bitcoin, you would probably add custom opcodes specifically around doing that parsing for you. That just kind of jumps to the endpoint of what you want to accomplish with the parsing. And also you need a lot of sandboxing to make it actually work safely, because you don't want things to kind of get outside of their sandbox and start giving capabilities to multiple children and other things like that. And it's very hard to do sandboxing right unless everything is written from the ground up to support sandboxing. Now, in Chialisp, there are no side effects other than coins getting spent and created, which makes sandboxing relatively easy. It really does come out as being like the language which is designed from the ground up to make calling eval reasonable. That in most programming environments, even ones which have it, calling eval is very, very seriously frowned on. There's a lot of I've written Python for many, many years. I don't know if I have called eval once after my first year of writing Python. And really do not understand a lot of the subtleties of the semantics of what happens when you call eval in terms of variable scope and things like that. And it's actually kind of terrifying to me to think what those might be. I have no idea what eval actually does in Python. But in Chialisp, or more specifically the CLVM. So Chialisp is on the same level as Solidity. It's a higher level language. The actual low level thing that's consensus critical is called CLVM. That is written from the ground up to support this. There are no side effects of any kind. And it is really, really normal in that environment to get a data structure, validate it in some way, and just call it. Just execute it as a program is a really normal thing to do, enabled by this pretty extreme adherence to no side effects. Okay, so next thing in terms of basic standard things that are used are cats. These are actually quite sophisticated in terms of how they're implemented. There is no way the community would be implementing these things if we didn't do it ourselves. So CAT stands for Chia Asset Token, call them cats. This is a colored coin protocol. It is very profoundly different from a colored coin protocol like Omni, because in Omni, if you get a colored coin, you need to be running a full node to know if it's valid or not. And in particular, the actual scripts on chain cannot tell if it's valid or not, like another coin can't. A smart coin, to the extent that you have smart coins in Bitcoin, have no way of determining the validity of one of these things. But cats, you can do this. You can actually determine the validity of cats. In ways that, again, I'm not going to explain how they work. It's really involved. So I just did say it's doing a lot with very little. And in particular, one would expect that you need to start gunking up your persistent state with complicated information if you want to support capabilities. And it turns out you don't have to do that. There are some tricks that do it. You can actually have kind of arbitrary other information that's stored persistently. It's hidden inside of coins that the more obvious trick is you have the Merkle root of stuff in a coin. Like the puzzle hash itself is a Merkle root, but it can on top of that know Merkle roots. I'm kind of looking into Merkle roots. That's a whole other subject. But you can hide arbitrary amounts of metadata in a coin. This turns out to be really, really a good idea from an engineering standpoint, that the Chia VM supports a little bit more transactions than the EVM does, but there's a distinction that the EVM Ethereum, running an Ethereum full node that's validating everything with some fudges about what that means, requires a fairly beefy machine to do it, where validating all of Chia can run in real time on a Raspberry Pi pretty comfortably. A lot of what's going on there is things are cost appropriately. It turns out that the main thing that's actually happening when you are running an Ethereum full node is it's doing these deep lookups as some large data structure out there. It needs to validate it. You can make Merkle proofs of things in this data structure, but those are kind of big. But the actual cost of doing the lookup involves, scanning around and things. And these, because of the way things run, it's kind of hard to parallelize them all and stuff. That in Chia, everything that happens in a block happens simultaneously. And you can just, in your local CPU, validate the entirety of a block. And only at the very end, put off all the necessary deep lookups to do when you're validating it. And all of those are of the form, this coin was spent, and here is the time lock on it, if any. It has to have a birthday before this date, or after, before this date. And that's it. And the entire rest of it can just be done in CPU. And of course, for each coin that's spent, a coin had to be made. And creating coins is one of your more expensive operations. So it is the costs are appropriate for how much it actually costs to do things. This turns out to be a really big engineering boon to the whole thing. There's a number of reasons why this architecture of the coin set model is a good idea that are really not obvious up front. So the solidity is kind of what you make if you've got a couple of weeks to crank out and you don't know any better, which is pretty much what happened, and is about the best you could do under the circumstances. But this is everything, and Chia is done after years of research had been done into what better ways of doing things are, and with a whole bunch of new ideas thrown in there. The whole approach to doing capabilities I'm very proud of, and that's done primarily with a programming trick, not actually adding much of any new functionality to things all. In fact, removing functionality because it has to be dumbed down enough that you can introspect formats reasonably. Okay, but cats support something really interesting. Chia, the way Chia coins get spent, they make outputs. And each individual coin isn't like super clearly tied to value. Like when you have a transaction, it's a bunch of separate independent coin spends, each of which shows here. For each coin, it has a puzzle. You present a solution to it, what in Bitcoin is called a script sig, which is, again, a name that makes sense to cryptographers and nobody else. But you present a solution to it. The puzzle is then run on the solution and it returns a list of conditions. So there are kind of two languages here. There's the CLVM, and then there's the conditions language, which we just call the conditions language. It doesn't have a real name. It can't do anything. It has no loops or control flow of any kind. It's just imperative statements, generally along the lines of create this coin, assert this time lock, make this announcement, assert this announcement from some other coin, those kinds of things. Pay a fee, but there's so each coin specifically makes some output coins, but where the amounts in the output coins come from is not very clear. The rule is across a block as a whole, the numbers need to add up. The sum of all the coins that are spent must equal the sum value of all the coins that were created. But it doesn't draw lines between them. It's just an aggregate value. The same is true of cats. We really went to some painstaking and slightly ridiculous lengths to preserve that ethos of the whole thing. So in Bitcoin, there are transactions, and each individual transaction has to net out appropriately. And in Chia, it's kind of like the block as a whole is one gigantic transaction.
Wait, so you say you can't use Chia to implement, you cannot use Chia to implement Bitcoin?
This is actually more flexible, but
I want to pay you to Bitcoins. How do you express that in Chia?
Oh, you send me 2 Bitcoins. You have a
just has to sum up correctly over the block, not over the transaction.
Right. Well, typically transactions in the mempool also sum up properly.
They don't have to.
Well, the mempool won't accept them if they don't sum up properly. But when you take a bunch of transactions that are in the mempool and make a block out of them, the boundaries between what those transactions were previously are kind of lost as you do it. It doesn't remember that information. As far as it's concerned, once it's in a block, there were a bunch of individual coins that were spent, and it does not aggregate together those particular coin spends into where they came from. There's some stuff about that I need to talk to you about, actually. That's a totally other subject. It's really normal to actually use aggregate signatures to kind of staple stuff together, that things can't be torn apart because you can't tear apart their aggregate signature. So cats support this as well. Now, the reason for this is really interesting, that it supports non-interactive aggregation is kind of the feature that's going on here, that this is kind of automatic, built into Chia, and implicit in the inner workings of cats. The solutions to cat spends were painstakingly designed to always be malleable, to allow you to move around where the funds went. This enables something really interesting. it allows you to make an offer that you can say, okay, well, I would like to trade this amount of Chia for this amount of this cat with somebody else. And you express this as making a partial transaction, a not valid transaction, that retires a bunch of Chia and prints a bunch of the cat. This is not a valid transaction because you can't just print cats unless the cat's tail allows you to do it. Every cat is defined by its tail, which is a program that governs its issuance rules. So if you want to add or subtract from the totals of the output, you need to get permission from the cat's tail. So, but you only rarely invoke the cat's tail. Usually you're just running the cat itself. One aspect of this is no one can grab your cats just by design. Even the person who controls the cat's tail is not capable of seizing cat tokens. They are in the possession of whoever it is that has them. It's a very intentional feature. So the okay, so you have this offer which retires a bunch of cats and prints a bunch of the tokens and is not a valid transaction because you can't do that. Often in the literature, people say burns for this. I like saying retires because burns sounds bad or all eco-friendly. Anyway, you can now publish this to, I don't know, 4chan or something. Maybe 4chan is old hat and you publish it to Power or something. Anyway, the point is you're publishing it to an untrusted system. And you are okay with doing this because all the worst that can happen is someone accepts your offer. So someone can see this and go, oh, I want to do that. And they make a balancing transaction that prints a balancing amount of Chia to what you retired and retires a balancing amount of the cat to what you printed. And they can then smush this together into what is now a valid transaction and will actually go through on the blockchain. And that'll go right through. So that's base level functionality for cats. A good example, I neglected to make a slide for. Our biggest smart thing to date actually is our pooling protocol. So, and that has to do with a good use of singletons, not cats. So our pooling protocol, which I will describe now, just pretend like I have a slide that says pooling protocol. Our pooling protocol, the idea is you want to make it so you can jump between pools. Like very intentionally, the farmer always makes the blocks, even when they're a member of a pool. And all the pool's doing is kind of smoothing out rewards for everyone who's a member of the pool. And there's some interesting untrusted interactions going on here that are kind of complicated. That there's some amount of time that it's going to take to jump between pools. And when you do this jump between pools, the pool can keep claiming rewards that you might make during this time when you're still in the pool. You don't want it to be that someone can actually make a block and go, oh, wait, I want to leave the pool and claim all the rewards for this block for myself. So our pooling protocol has fixed 1/8 of the value reserved for whoever happened to find the block, just to incentivize people to make blocks even when they're members of pools. I shopped around this idea to people before rolling it out, and everyone's like, yeah, sure, whatever, which kind of surprised me how nonchalant they were about it, but okay, cool. The hook on the consensus level for supporting pools is really interesting. You've two options for plot formats. One of them, all rewards just need to be signed. There's just a key that's given that will sign off where the rewards are going at the time the block is made. The other one, all rewards go to a particular puzzle hash. So the puzzle hash is fixed at the time you make the pool, not fixed at the time when the block is made. And almost everyone uses these because they support pooling protocol. Again, it's not obvious that they support it at all. It looks like way too underpowered of a hook to actually support that, but it totally does. And it was done specifically because we wanted to support a pooling protocol, which was a whole adventure in and of itself, because when we first launched, NetSpace immediately, and price was way higher than we expected, which caused NetSpace to go up a lot, which caused everyone to freak out that we didn't have a pooling protocol yet. So it took us 2 months and a week to get out our pooling protocol, during which time I got no end of harassment about how long it was taking, because, oh my God, 2 whole months to do a whole protocol. Anyway, so the way the pooling protocol works, actually, that puzzle hash of where the things go to is a pay to singleton. It says, in order for me to be spent as a coin, I need to be told by the singleton to go get spent. And then when you join a pool, you are locking your singleton into a state where it takes some amount of time for it to get out of that state. But while it's in that state, it can claim rewards that any block rewards that go to it, it can say, oh, I'm grabbing those now, and I'm sending them to the pool, right? And this makes it so that the pool knows that when you're a member of the pool, any block rewards that you happen to get at that time, they can then claim, and they have plenty of time to claim it without getting into a ridiculous race for that to happen. So this is actually a fairly sophisticated smart contract thing, smart coin thingy thing. It actually uses our old singleton format. We improved the singleton format since then. Obviously, that was the very first thing done. Our CATS format is currently on version 2 because there was a critical security problem in version 1, which is the thing that happens sometimes. Really good idea whenever you get a formatted thing and you're told that it composes a few fields, to check the lengths of those fields. just a thing. Anyway, so I got reassurance that we were in fact paying something for that audit. So there may be new singleton and cat standards in the future because of new thoughts we have about how to do things. That gets kind of involved in esoteric. But those are, pool protocol is by far the biggest thing in terms of what's deploying on Chia now in terms of smart cards. But we have all kinds of other stuff built and in the pipeline. One of them that I'm super excited about is a rekeyable wallet. When you use a bank, they're providing some security services for you that if you want to try and do various things, they put rate limits on how quickly you can do things and slow you down if you try and exceed the rate limit. They do this in a way that has no transparency and end user control whatsoever, but these are real security services where using Bitcoin feels like carrying around suitcases full of $100 bills. Now, in principle, cryptocurrencies should actually be much better at these sorts of things than banks are, that you should be able to specify exactly the business logic that you want with full transparency and end user control over the entire thing. By the way, my personal sense of time is horrible, and it looks like I've already been talking for a while. So, but let me know when I should stop talking. 10 more minutes. Okay. All right. So I'm not going to get through very many of my slides at all, which is fine. So I did this exercise. So we have our preform, and we want to hold it in something that's actually good. So we made a custody solution for it. Unfortunately, people don't get excited about better custody solutions. It's really annoying because custody solutions are what the world needs. What the world wants are more Ponzi schemes. But what they need are better custody solutions. In In 2000, I forget which year. There's been so many booms and busts over the course of my life. At one point, The Onion ran a headline, which is Americans protest to Alan Greenspan, demand new asset bubble. Anyway, it turns out if you actually go through and say, how do we want the business logic of a good custody solution to work, of just a multi-sig wallet? We have a multi-sig wallet. What should the business flows and the business logic of it be? I tend to just cringe whenever people say business logic, because the people who like saying business logic tend to be the douchiest people on earth. But it is a real term. It does mean a real thing. I actually did geek out on business logic on custody solutions. It turns out you want to use rate limiting in various ways, but the end result of the whole thing for your very most basic custody solution is it has some number of keys, and any number of keys can do stuff. But if there is an argument between differing numbers of keys, then the larger number of keys will just outvote the smaller number of keys and get them to go away. If there's equal number of keys trying to argue about different things, they get into a deadlock situation and the funds simply don't move. And there's various ways you can use timeouts to enforce this, giving people enough time to notice something has been initiated, and stop it, undo it. And sometimes you want below some thresholds to use things so that you can't even like DOS it. You want it to be that if you control simply one key, then in the normal course of things, the funds are moving around enough that you're not allowed to do anything. Like one key by itself can only really do stuff if everything's just been locked up for a while. But that's all in the details. Mostly it's larger numbers of keys wins, really, really basic logic. And it's really kind of terrifying working on that, because it's not because it's insecure. It's great. It's like, oh yeah, this is totally reasonable. It's terrifying is the fact that it's never done ever. This is like security 101, really, really basic stuff. And people don't do it. Anyway, we have built this. We're going to productize it. Maybe people don't implement the exact thing that I just said, which seems like a really basic fundamental thing when you're doing custody.
This is not a multi-sig, or what?
It's multi-sig, but it's not. It's rekeyable multi-sig. If you try and when you say here, I have 3 of the 5 keys, it doesn't just immediately yank the funds out of the thing. The funds go into the state where they're held for a while, where they can be returned to the wallet also using 3 of the 5 keys.
Oh.
Yeah. And you can also, well, anyway, there's a few good details of implementation on that.
A couple of days or what?
In this case, 90 days, but it's a configurable parameter. But we wanted it to be 90 days, not for business reasons, not security reasons, to make a technical enforcement of our statements that will give 90 days notice of various things happening. So that was set a little high, but like a month, or it's a configurable parameter. So you could send.
We're drawing funds from a custodian from his wallet would take a month.
If you set it that way, yes. But if you're doing super high security cold wallets, you tend to have long things. Because
what is the point of this timeout? Like if 3 of the keys are adversarial,
yeah,
and they request a withdrawal, then they will not contest during these 90 days.
Well, you can have situations where a key is controlled both by an honest person and a dishonest person. That a key was not, a key was not stolen, it was sniffed, which is kind of much more common than actually completely stealing it. Or gave away access to one of their copies of a key to someone they shouldn't have. So you have overlaps in your set of keys between the honest and dishonest parties to the thing. It is actually
compared to like Bitcoin vaults.
Yeah, usually you can, if you get your threshold, you can just yank all the funds. Bitcoin is not very sophisticated in terms of what it can do. Some aspects of this could be done using Bitcoin, but that gets kind of involved and complicated and has more to do with what Bitcoin's limitations are and how you can hack around them, which I'm not super well versed in. I think of Bitcoin's script as kind of busted Chia Lisp, and I'm not really sure exactly what its limitations are and exactly where you can hack around it. I generally speaking do not try and do my engineering in a way where I'm optimizing for how easy it is to repeat the exact same thing on Bitcoin. I'm just doing it in Chia. So some of the things can be mimicked in Bitcoin and some of them can't, and I can't really tell you exactly which ones can and can't off the top of my head.
What does the word rekeyable mean?
What? Your rekeyable means you're changing the keys to the wallet. You're changing what the signing keys are. So
where in this process I missed. So you do 3 out of 5 sign.
Yeah.
It goes into this escrow state, and then a month
later. So rekeying is a different process. So there's 2 different operations you can do. You can withdraw and you can rekey.
Oh, okay.
Both of them are subject to a delay, during which time the operation can be canceled.
Now, who's going to do the arbitration? Like during the 90 days, someone must claim that, oh, okay, this is a misuse.
There's a coin that has rules that are also multi-sig.
Okay.
So that the 3 of 5, so like 3 of the 5 keys were used to initiate a withdrawal. That makes a coin. That's a withdrawal coin. The rules of that coin are after some timeout, it just goes to wherever it's supposed to go. But until that time, any 3 of the 5 keys can turn it into a pay to singleton, pointing right back to the wallet that it came from. After which it can get claimed by that wallet. Although the wallet might be rekeyed or something. It's not uncommon for it's not uncommon for the wallet to be in kind of a messed up state at that time. But there's no timeout on when the claim by the wallet can be done. That can be done forever. So if at any time in the future the multi-sig wallet gets itself sorted out, then it can claim these funds.
Can you say, is this actually being used heavily in Chia?
Well, we have, over $500 million worth of Chia that we put into it. So
no, that's you.
Yes, that's us. We have not productized this yet. So, but we fully plan to productize it as a just basic functionality. Okay. So that's something that I'm excited about. Other people aren't, but okay, then we have data layer, which is not the greatest of names. The data layer is an oracle that reports a Merkle root. That's what data layer is. And you have off-chain auditing of what it is in that thing. That's kind of optional as far as the on-chain stuff goes. But you have a singleton that just reports a Merkle root. This actually is very cool. It enables all kinds of stuff because this is validatable. You can do things where someone like offers to pay someone for something else, which an oracle is reporting. So it can be like, here's a bunch of funds that I have locked up on chain that are claimable by you up until this time, if this oracle reports that like I now own this motorcycle or something like that, because I'm trying to buy a motorcycle from you. And then you bring me the motorcycle or sell it to me or something, change the title to me. And these funds are now claimable by you and you go claim them. Maybe we actually make it so you don't even need to check the Merkle root because I see that you could, and then I just sign them off directly to you. But because there's an early sign off process, but that's that's very cool functionality. It turns out, again, in terms of really super basic functionality, oracles are kind of nice because it makes it so you have an oracle instead of an escrow agent. Escrow is expensive and ridiculous because you are trusting a third party to just not steal everything. Where oracles, the threat model of an oracle is they would actually need to collude with one of the 2 parties to get anything done. And that's a much, much easier bar to meet with a lot less risk, particularly for the oracle reporting agent. So this is very cool functionality as well. We are using this actually for something very real that we are working with the World Bank for implementation of the Paris agreements about where carbon credits go. So all the carbon credits are going to be reported on chain using data layer. They are primarily interested in the auditing function capabilities of data layer, not so much the enabling of commerce on top of it, but they're getting it anyway. So let's see. I think I'm pretty much out of time here, but fine. Okay. All right. So I will relatively quickly go through. So we support NFTs. Our NFT standards big claim to fame is payments to the original person are enforced on chain. Now, trivially, you can just lie about how much was paid, but you're doing this publicly. There's a public shaming component to the whole thing that everyone can see that you committed this fraud when you do that. So that's what we're doing in our NFT standard.
So like in the Ethereum world, you don't have to do any chaining. You're guaranteed that then if NFTs pass the creator this page. Why do you have to rely on
No. It asks. It just says you should pay here, and you don't actually have to.
No, write an NFT contract where every time I sell the NFT, the creator gets paid.
Well, they don't. That's not how the NFT standards work. They don't enforce it. Also, there's a sort of technical.
You're actually right. I mean, but you could implement this.
Well, there's kind of a technical problem with a lot of this stuff.
In Ethereum, you can actually enforce this in a contract.
You could.
In Chia, you should be able to enforce it in a contract too, programmatically. Without having to rely on chaining.
Well, you need to know how much was paid for the thing. So.
But isn't that recorded on chain? So.
Well, yeah, but you have the sender and the recipient both opt in to the amount that was paid. But they can collude and lie, which they are incented to do on some level.
Oh, that's what you mean.
Yeah.
I see.
Instead of very mobile.
Sure.
Yeah.
Okay.
So, okay, another thing we support or will support, this is getting into things we don't support yet, are AMMs. AMMs wind up being actually a very different beast. You have an AMM is kind of pairing, let's say, Chia and some cat with each other. And so now there are three values here. There's Chia, and there is the token that it is pairing it with, and there is its own internal use token that it's giving credit for. It does not itself custody the internal use tokens, and that is itself a cat. That cat's tail says that this one singleton is able to change the balance. And the business logic of the AMM itself actually is that it knows three starting values, which are the amount of Chia that it itself is sitting on, the amount of the token it's pairing that it itself is sitting on, and the amount of issued internal use token that's out there. And then it has three new values, which are the updated values of these. And its business logic basically is entirely just, is it okay with that transition between these? And that's it. And so it's kind of accepting offers for trade. Is the entirety of what it's doing. And so instead, so like Uniswap acts as a bookmaker and a liquidity provider and a price oracle, where this is not acting as a bookmaker. Someone else needs to make book. It's just acting as a liquidity provider and a price oracle. And has the benefit that it's only announcing one price per block. Or you can have a Schelling point singleton, which repeats what it says, which only allows one price per block. And that, it turns out, actually has a lot of benefits in terms of stopping MEV. MEV is a bad thing. It's not good. There just should not. You want to minimize MEV. You don't want to talk about the MEV industry around what you're doing. That's bad. But the one kind of silly sounding thing that reduces MEV is you can have a price oracle that doesn't have any security on it. That the only thing that the price oracle guarantees is that it only reports one price per block. And this turns out by itself to already have quite a bit of anti-MEV properties because
you have two AMMs and they disagree on the price. Immediately you have that.
No, you have a bunch of offers and they say, I am going to go through within some tiny delta of the price reported by this price oracle. Now, the price oracle can be from an AMM, which is giving you some somewhat reasonable notion of what the price is. Although even without that, even if the only guarantees from this price oracle are that it only reports one price per block and that other people are also using it, it actually helps a lot with MEV because it means that the price reported, it can be high or low, but it can't be both in the same block. So whoever's making the block can't. Yeah. There's always some friction in markets, but you want to get rid of the most trivial things where you just line up things and just outright pocket the spread. Yes.
Actually, there is someone doing similar things, as you said. It's called batch transaction.
Yeah. These are, yeah.
But it's a good idea to avoid that.
Yeah. There's a bit of a vibe about MEV in Ethereum that I do not approve of.
Current thinking is that MEV is unavoidable.
Yeah, but using that, you set a small delta and everyone has a bid and ask. And then you kind of like
there are people in the Ethereum system who are doing things to help with MEV at the same time as they're working on baking it into the consensus layer. Anyway, not the same people. I must be out of time by now. Okay, I'm also implementing poker on chain. Which, oh yeah, I know everyone gets excited about poker. No, that poker is what I actually have been spending my time working on lately. I personally am implementing this. It's based, yes. It is very similar to Hold'em because using a permutation of cards is a skeuomorphism and is very difficult to do with multi-party computation. So I'm making it be a mapping, not a permutation. But it is very similar to Hold'em because that's not a particularly important part of Hold'em rules. Anyway, it actually supports generalized two-person turn-based games. You can do poker over that because there's commit and reveal. You could, in principle, actually support legit, like verbatim Hold'em using a bunch of really interesting zero knowledge stuff that is its own very interesting project, probably practical with current technology between two players, but not important for what I'm doing right now. So probably we'll get to it eventually, and that should be really fun. But I have a bunch of thoughts on that.
So is this launch open or not?
No, I am working on it. I am current status. I have figured out an initial batch of games to support for it and their rules. I have extensive notes about how exactly all this works. So it kind of goes into layers that there are game coins where we can play a game on chain, where we alternate taking turns. Those kind of are inside of a state channel. And so I figured out how the state channels will work. I am in the process of implementing the game coin. The thing I have working right now is rock, paper, scissors. I have the validation program for rock, paper, scissors working. I am in the process of implementing the game coin, which I just changed a bunch of things the other day. But anyway, and then once that's done, I will go and implement the state channel coins. And then I will, which are very simple. I'm using a modified version of EL200 on it. And then after that, I will make like probably.
You said two-player games.
Mm-hmm.
So poker is not a two-player game.
There are variants of it that are two-player. It's called Heads Up.
Oh.
They're actually pretty popular now.
Shorthand. But aren't the most websites that do poker isn't it multiplayer?
Heads Up has actually been getting more popular lately because
for large amounts, they like to go heads up, so you're not being cheated by anybody. The team isn't, you're not.
Poker in multiplayer games, there's a tendency to allow collusion among multiple players. Poker is relatively good for that because people drop out of hands early and then you can't collude in a hand that you've already dropped out of. But there's still massive opportunities for collusion even then. Actually, Hold'em, it's really messed up because people can just tell each other what their whole cards are. But there's also various forms of fuckery where somebody raised and then somebody called, and then you allow your friend to re-raise where normally you would call and you just do a min raise in the situation to,
For the very
yeah.
highest amounts, it's usually just two people.
Yeah.
It's just, it's.
Like
it
if,
helps
for
them.
like billionaires or payment, they only pay using a heads up, two people.
It's two players or you against the house?
just
No, two players.
Player versus player, two players.
Yeah.
That way.
Yeah.
there's not a third party who could babysit.
Poker is a relatively good fit for on-chain gaming because it is a game designed for assholes who don't trust each other. Yeah, which is, yeah, so you have a very similar situation with on-chain gaming. So it's actually a quite a good fit.
That's very interesting.
Uh,
So I see, so really, generally on sounds like on-chain gaming would mostly be two players.
Yeah, gaming is a big,
I think it's multiplayer. Design a three-player game where collusion doesn't help.
yeah, yeah,
I'm not for just a multiplayer game.
Yeah, I guess.
yeah, so in terms of multiplayer games where collusion doesn't help, if it's an elimination tournament, collusion doesn't help.
But
And if it's a race, collusion doesn't help. Yeah,
But any multiplayer game, in some sense, it can just reduce to two-player game scenario.
Oh, you can emulate.
Yeah, because in some sense, if you have a big MMO RPG, then you only need to design a two-player game. For instance, in The Witcher, which is divided of kind of two-player game component, which is for two players, but there's a multiple player that you can just play with each other, and you can rank for the best players.
even the simple problem of making a 3-participant state channel where there isn't collusion fuckery possible is not trivial at all. Yeah. So anyway, I am adapting the game to the medium that it's on. Also putting a Wordle variant on it, a Wordle based game on it as well, because that's hip and also happens to be a good example of usage in it as well. So I'm going to have a few games that hopefully people like on their own merits as games and are also just demonstrations of the platform for what I'm working on. But that's, it's a bit of a project. I am still working on the basic fundamentals of it, which tend to be, there are things that are hard because they're hard, and there are things that are hard because they're subtle. And this stuff is really, really subtle. It's no deep math. It's all just sort of like plumbing that has a lot more involved stuff. I mean, I guess that's typical of MPC just in general, but you know. Okay. Oh, and then I'm gonna, at time, yeah, okay. And then also working, gonna have a payment channel network based on routing state channels in a slightly new way. That's kind of interesting. We're making a bridge from Ethereum. We're going to support DAOs. All right.